Good morning. My name is B. Selvam, Assistant Professor Mechanical Engineering in Kongonadu College of Engineering and Technologies. My talk about the subject name Dynamics of Machines. The Unit 1 Force Analysis and Turning Moment Diagrams. Force analysis can be divided into two types. One is the static force analysis, another one is the dynamics force analysis. Static force analysis, the analyzing the forces and their effect in a system, ignoring the inertia forces due to the mass of the missing element. Dynamics force analysis, the inertia effect due to the rotating or reciprocating parts is considered in addition to the externally applied loads. Such a force analysis known as the dynamics force analysis. Then inertia force. Inertia force an imaginary force which when act upon a rigid body bring it to an equilibrium positions. This the value is numerically equal to accelerating force but opposite directions. Inertia force is equal to minus m into a. Next one, inertia torque. Inertia torque is an imaginary torque which when act upon a rigid body bring it to an equilibrium positions. It is equal to accelerating couple in magnitude but in opposite directions. Inertia torque is equal to minus I into alpha. Next one, D'Alembert principle. D'Alembert principle state that the inertia force and the torques and the external force and the torques acting on a body together result in statically equilibriums. Next one, force on the reciprocating parts on engine neglecting the weight of the connecting rod. This is the diagram for reciprocating engines. The reciprocating engines, the various force acting on the reciprocating parts on the of a horizontal engine. First one, piston effort. Piston effort is defined as net or effective force applied on the piston along the line of the stroke. It is denoted by Fp. Mr is equal to mass of the reciprocating parts. That example pistons, gasket pin or hudson pin etc. in kg. And Wr is equal to weight of the reciprocating parts in newtons. We know that accelerating of reciprocating parts, the accelerating force or inertia force of the reciprocating parts. Piston efforts F is equal to net load on the piston plus or minus inertia force. Net load on the piston Fl plus or minus Fi, neglecting the friction resistance. Fl plus or minus Fi minus Rf, that is considering the frictional resistance. Rf means frictional resistance. The sign negative sign is used when the piston is accelerated. The positive sign is used when the piston is retarded. In a double acting reciprocating steam engine, net load on the piston Fl is equal to P1 A1 minus P2 A2. P is the pressure, A is the area. Then P1 A1 is equal to pressure and cross sectional area of the back end side of the piston. P2 A2 means piston and cross sectional area on the crank's end side of the piston. Small a is equal to cross sectional area of the piston rod. Second force acting along the connecting rod, that is Fq. Fq is equal to Fp divided by cos phi. Then third force, thrust on the side of the cylinder walls or normal reaction on the guide bar. Fn is equal to F2 sin pi is equal to Fp divided by cos pi is equal to Fp into tan pi. Then fourth force, crank pin effort or and thrust on the crank's soft bearings. The force acting on the connecting rod Fq may be resolved into two components. One is the perpendicular to the crank, the another one is the along the crank. The component of Fq perpendicular to crank is known as the crank pin effort and it is denoted by Ft. Then fifth one force, crank effort or turning moment or torque on the crankshaft. Crank effort is the net effort, that is the force applied at the crank pin perpendicular to the crank, which gives the required turning moment on the crankshaft. Crank effort is the product of the crank pin effort and the crank pin radius. Crank effort is equal to Ft into R. The next topic, turning moment diagrams. Turning moment diagrams is the graphical representation of turning moment or crank effort for various positions of the crank. The torque of an engine crankshaft varies considerably throughout the working cycle due to variation in the crank positions, the pressure in the cylinder, and the inertia force on the piston and the connecting rod. If the value of crankshaft torque, that is the turning moment T, is plotted against the crank angle theta, the diagram so obtained is called turning moment diagram, where Ft is equal to piston effort, R is equal to radius of crank, N is equal to ratio of the connecting rod length to radius of crank, theta angle turned by the crank from inner dead center. From the above the expression, we see that the turning moment T is 0 when the crank angle theta is 0. It is maximum means when the crank angle is 90, and it is again 0 when the crank angle is 180 degrees. Turning moment diagram for 4-stroke cycle internal combustion engines. This is the internal combustion engines. The turning moment diagram for a 4-stroke cycle internal combustion engine shown in figure. We know that in a 4-stroke cycle internal combustion engine, there is one working stroke after the crank has turned through 2 revolutions, that is 720 degrees or 4 pi radians. Turning moment diagram for a multi-cylinder engine. A separate turning moment diagram for a common steam engine having 3 cylinders, and the resultant turning moment diagram is shown in figure. The resultant turning moment diagram is the sum of the turning moment diagrams for the 3 cylinders. It may be noted that the first cylinder is high pressure cylinder, second cylinder is the intermediate cylinder, and the third cylinder is the low pressure cylinder. The cranks in case of 3 cylinders are usually placed at 120 degree to each other. The next one, maximum fluctuation of energy. The difference between maximum and the minimum energies is known as the maximum fluctuation of energy. Coefficient of fluctuation of energy. Coefficient of fluctuation energy is defined as the ratio of maximum fluctuation energy to the work done by cycles. Coefficient of fluctuation speed. The difference between maximum and minimum speed during a cycle is called maximum fluctuation of speed. The ratio of the maximum fluctuation of speed to the mean speed is called coefficient of fluctuation of speed. Thank you.